Have a good day.
See ya Thursday.
Ashley, we didn't have homework, right?
No, we took it out.
Okay, good. I was just thinking, I was like, did I have homework? Like, I thought like this. I'm just so happy.
I am.
I
I'm
thought
so
you
glad
had
it's
to-
over too.
Oh, well, that too, but like, I'm just so glad. I'm up to like a 95 now. Well, that's good. But that means we have to like keep doing good. We can't just, you know.
Look, he already got the chapter 6 done.
I know. I'm like, what is this? But he doesn't have a date, so that means it's not true. Yeah. That's good. Oh my gosh. Did I try calling on my face yesterday? You're taking hot. And it's like, because I'm really like woke up this morning.
The whole weekend was fun. It's fun.
I know. Why does it happen like that?
All 3 days.
It's
Not
like
bad at all.
Sunday night.
I
after I take a
actually had to go to school.
Exactly. It's like Sunday night after I take a shower, I look in the mirror and I'm like, what is this? And I'm like, I love I could literally go during classes because I just love it. Because obviously it's gonna leave scar or whatever. It amazes me so much. Yes. I'm tired too. Actually, I said I'm not tired anymore. I was during second period. I was tired during second period. It's like anatomy, and it's like I sit in the front, and I'm like,
I'm just ready to go home. It's awful.
like then I get to this class. No, it's not too bad. I think I like this class. Lunch is like right in the middle of
Yeah,
it, so I can like look forward to lunch.
This class is a short one.
Oh my gosh. I think we should have 4 day weeks. Every week. Yeah. Like 3 day weekends are just
Yeah.
amazing.
No, it's weird having 3 days, but it's still best.
Yeah.
Because it's much longer. Yeah, it's I'll take it.
Oh wait, I'm not even gonna be here because we have swim space.
Oh,
Yeah. I forgot about that.
Oh
my gosh, how was it? I heard about it.
Why do you have a kid? Is it your birthday?
Like lost or something.
Okay, she just had 7 girls.
What the guys But that's like usually what we do. I was gonna say
No, you should.
I feel like I have something to talk to you about. Really important. Oh, teaching because
You got the distance.
okay, I don't know. My grades probably went down.
So I was confused because I did better.
No one plays school difference.
But it went on a
You missed Dryden?
Lauren's good business.
Who hydroponics?
Why are you only?
All right. There was 2 handouts on the desk up there, but one of them you guys should have already had. And I'm switching the order of this just a little bit from what I told you last time. Okay, so the one on slope fields is the one that you guys picked up last time. Girls, get settled in, please. And you probably didn't number it because you picked it up after part of our test this time last week, so it's number 91, and you will need it here in a bit. You also need a new piece of paper for number 92, which is the one you guys picked up this morning. So when we came back from winter break, I kind of broke down the units for you, and this was the one that I said for most people is the easiest unit that we have. It's our next to last new unit, and it really has 3 type of questions, 3 new type of questions. One is slope fields, which I'm going to show you here in a bit, and it's probably the easiest calculus thing we do all year. Yep.
Will we have tests after spring break?
You'll probably have one more test that'll fall after spring break. We aim to try to cover all the new stuff before spring break, but we usually fall short of that by a week or 2. So, okay, so slope fields, which most students think is probably the easiest thing we do all year. There's one where we use some exponential growth, exponential decay questions, which are not too different than what you have used in the past. So that's usually just one day, and students don't usually worry about that one. And then there's the third topic. There's one that does take quite a bit of practice, and that is called separation of variables. So I thought today on 92 we would do some of this handout. Some of these questions are not going to fit on here, by the way. That's why I said you might need a separate sheet of paper. It's also fine to do them on the back, but on the longer questions, do not scrunch them into that tiny little space. Probably the hardest part of these questions is really just that they're kind of lengthy, and it's easy to make careless mistakes, and if you're scrunching your work in, then it's going to amplify that. So I want to do a little bit of that today, just so you guys are exposed to it, and we will practice that a couple more times before we get to our next test. And I just thought maybe exposing it to you early gives you a little bit more time to digest that information. So the first thing we're doing, this 92, this will be the hardest part of your next test, but again, we're just kind of starting it off today. Okay, so separation of variables is still going to be integration. And the name will make sense here in just a second. But in question 1, this is saying find the general solution. So general solution means you need to put a plus C somewhere in your question. General, we don't know the exact specific solution. Whereas halfway down, we'll do a couple of the particular solutions where you do have to solve for C. And to find the solution to a differential equation, that means we would like to know what was the original equation. That's what we're asked to do here. Now, what you may be tempted to do at first is to try to integrate both sides. And you can integrate this just fine. You would end up getting y. But over here, this is kind of problematic because you've got x's and y's. So before we do calculus, we are going to do separation of variables. So that just basically means put all the x stuff on one side and all the y stuff on another side. So for this one, let's multiply both sides by y squared and multiply both sides by dx. That is the separation of variables step. Now again, we're only going to do a few of these today, and I told you this is going to be the hardest part and the part that takes the most practice, so you don't need to feel like you have this skill memorized or mastered by just a few examples today. But I will tell you that when this shows up on FRQs, and it's pretty often, of the 9 points that go along with FRQs, when this shows up on FRQ, it's usually 5 or 6 of the 9 points, this one particular skill. So that is the separation of variables step. Get all the y stuff on one side, get all the x stuff on the other side. Then we want to integrate both sides. So as long as we do it to both sides, it stays balanced. So, and this, it's kind of the first time where this dy dx stuff really matters and need to keep up with it. If this was y squared dx, that would mean something completely different. But the fact that these variables match mean that we can just raise the power by 1, divide by the new power. Over here, these variables match, raise the power by 1, divide by the new power. And what else should I need with the integration? Plus c. Now technically I integrated here and I integrated here, so we have plus an unknown number here, plus an unknown number here, but you only need to do it once, because if you subtracted this unknown number from this unknown number, you're still going to have an unknown number. So you only have to remember the plus c once, but you do have to remember it. And if what I really want is y equals, and sometimes it just depends on if you're going to keep going, but I can multiply everything by 3. So you think I should call this 3c? What's 3 times an unknown number? It's still an unknown number. So it's still going to be just c. And then how do I get rid of a cube?
Take the cube root.
So there is the general solution. General because it has the plus c in it, and it's a solution to a differential equation because we have figured out what the original function was. So we have to separate variables, get x stuff on one side, y stuff on one side. Sometimes that's easy, sometimes that's a pain. Then we integrate. Sometimes it's going to be easy. Occasionally you're going to have to do u substitution. Not forget the plus c, and then solve for y. So just a lot of steps to it. But okay, let's look at, let's do a couple more from this side. Okay, so to integrate this, you want your variables to be split up. So let's multiply 2y cubed to both sides, and then multiply both sides by dx. Now I've got all my y stuff on the left, all my x stuff on the right. Also, by the way, if you rearrange these in some way where your dx was in a denominator or dy was in a denominator, that doesn't make sense. You always want the dy dx to be in the numerator. Okay, what did we do in question 1 after we separated the variables? Integrate both sides. So raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Luckily, no u substitution in here. Don't forget the plus c. And then, of course, if it's multiple choice, you need to start looking at your answers to see how much further you need to go. But on FRQs, they always expect you to finish solving for y equals. So you can multiply everything by 2. C times 2 is still c. Unknown number times 2 is still an unknown number. And then to get rid of to the 4th power, take the 4th root. So 4th root of 12x minus 2/3 x cubed plus a c is what the original equation was. Okay, so you guys okay with why I'm separating the variables? You see why that's necessary? Okay, and then the integration. Ava, you need to put your computer up. Everybody okay with the integration? And then the solving for y. Okay, then you've got the general idea. Again, the only thing that could be more, each one of these steps could be more difficult. Separating the variables can be messier. The integration can be harder if it's u substitution. And the solving for y can be messier, just depending on the question. But you've got the general idea of what separation of variables is trying to achieve. Okay, now it doesn't have to be x's and y's, it could be r's and s's. So just like here, I solve for y. In question 3, I want to know what r is. What's the original function for r so that his derivative is 0.75s. And I'm going to write that as this. So you should first separate the variables, put dr stuff on one side, and all the ds stuff on the other side. Technically the number you can do either way. The 3/4, if you'd rather this be 4/3 here than 3/4 here, that doesn't matter. Your answer will still come out the same. I usually just don't move it because I don't want to do any more work than I have to. Integrate both sides. How does this integrate? What does this become? Very good. That's an understood 1. We know it's an r, not an x, because of the dr. This is why we have to have that as part of our integration. Over here, raise the power by 1, divide by the new power, and then don't forget your plus c. And usually we solve for y, but this question we would be solving for r, but it's actually already done. So now, one thing I think you guys don't do quite often enough, and I kind of get it on like a question 2, this is such a messy answer, but on question 3, this takes about 2 seconds to take the derivative. I can check, bring the power down, lower the power by 1, the derivative of the constant is 0. You can see that the derivative was 3/4 s, which is what the derivative of mine is. So always consider doing that. Okay, let's look at one more like this, and then we will do 5, 6, 7 of this type next class. So if step 1 is supposed to be to separate the variables, this is not written as a dy dx. So if that's not the case, then make that your first step. If it's got a y prime instead of a dy dx, just rewrite it so that it is a dy dx. Okay, so now I've got to separate my variables. Do you think the x stuff should end up on the left or on the right? The problem with on the left is if you leave it on the left, then dx is down here in the denominator. I need dx to be in the numerator. So if I multiply both sides by dx, then x stuff's going to the right, y stuff can stay on the left. How do I get this x over to the right? Okay, so 1 over x, and then move this over with divide. So I would say that's a little bit harder to separate the variables, but it is still just random algebra stuff. Then we should integrate. To integrate 1 over y, that would be natural log of the absolute value of y. Integrate x, same thing but an x. Still can't forget our plus c. Now, this is very unusual, or I'm sorry, it's not that unusual in this question type, but unusual algebra in that you may have never even seen this before. Maybe your pre-cal teacher showed it to you just for a second, but again, the point of this is for me to get this down to y equals something, not natural log of y. That's not the same thing. Also, I can't just divide both sides by a natural log because this is not natural log times y. It's natural log of y. So there's really only one algebra trick, and again, this is going to come up a lot in here. So you need to put a star next to your work here. We are going to what's called exponentiate both sides. So I'm going to make the left side an exponent on e, and I'm going to make the right side an exponent on e. That's fair game to do because I'm doing it to both sides of the equation, and that keeps that balance. Now the reason why we do this, you may also want to write this on your paper. There is a logarithm property that you're asked to memorize as early as Algebra 2, and it doesn't really have any context to why you need to know it. But if you have a number to the power of log and the base is the same number of something, all of this just comes out to be that something. This is what's happening right here. E to the log base e of the absolute value of y is the absolute value of y. Now, we're not going to worry too much about the absolute value part today. There'll be a day where we focus on that. That's the only way to dig that y out of the natural log, is by exponentiating and then applying this logarithm rule. Okay, over here, when you add exponents, just like x times x is x squared, that means you are multiplying them with the same base. So we will often write it like this: multiplying things with the same base, you add the exponents. And then this is that same property again. A number to the log of the base is the same number of something. Again, don't worry about the absolute value part. I'll help you worry about that another day. And then what about this? What is
Would it just be C?
right? Just going to be C. The number e to an unknown power is just some other unknown power. We're just going to call it C. So again, you don't need to worry about or stress about today, but I think it helps for you to see that exponentiating is going to be a very common step. And so this property should be written at the top of your page, and you should have some star or circle that step, because that's kind of important. Okay, so let's save a couple of the general solutions for next time. Again, I think splitting this up into a couple different pieces can help. But now let's look at maybe 8 and 9 on the bottom. So what's different here is that it says find the particular solution. So they give us enough information that we can solve for C. We just should not have a C in our final answer for these questions. Okay, this is not going to fit here, so if you need to do it on the back, that's fine. Okay, so we need to separate the variables. But first, I should write this as dy dx so that I can see. And then to me, since dy is already in the numerator, I'm going to say that that's going to stay on the left. So I could subtract this guy over and then multiply both sides by dx. And then now that this is just y stuff and this is just x stuff, we can integrate both sides. Raise the power by 1, divide by the new power. Let's say I only want to do one integration. If this was an FRQ, what's wrong with what I wrote down so far? Right, so even though I only integrated 1, and you only have to have 1 plus c, you didn't really integrate this if you don't at least write plus c once. So if you only want to do half at a time, that's fine, but you better not lose the plus c. Okay, I'm going to just do the plus c over here. So raise the power by 1, divide by the new power. Okay, this is where things can get kind of tricky if you don't have a plan. So it said there's an initial condition at 0, 3. So that's going to allow us to solve for C. Now, you don't have to solve for C at this step. You can do some work, you can simplify some first and then plug it in. But what you have to be consistent on is you have to plug it into where you started solving for it. So what I'm saying is, if I say let's multiply everything by 3, because that makes it look nicer, if you say that this is now c instead of 3c, it's not the same c anymore. So that's fine, but wherever we start solving for c, that's where we have to plug c back in. So what I'm saying is, if I plug it in here and solve for c, but then I plug c in up here in a different spot, then it was a different c that we were solving for. We just need to be consistent. Okay, so I'm going to go ahead and plug it in here. Everywhere that y is 3, x would be 0. So the right side goes to just c pretty quickly, but over here this would be square root of 27, which is 3 square roots of 3, or 6 square roots of 3. And then wherever you started solving for, I started solving for c at this step, that's the step I better plug it into. If I plug it in up here, my c is 3 times bigger or smaller. I can't figure out which one, but then it's supposed to be. So plug c back in for where you started solving it for, so that you're sure it's the same c, and then solve for y. So maybe divide everything by 2. And then to get rid of this square root, we would square both sides. And to get rid of the cube, we would cube root both sides. So I'm just going to leave it an exponent. This is what I meant by longer questions. And this is why when they show up on an FRQ, they are usually 5 or 6 points. So not that you're interested in this just yet, but usually they give a point if you separate the variables correctly. Usually they give you a point if you integrate both sides correctly. Usually they give you a point if you remember the plus c. Usually they give you a point if you try to plug in the initial condition to solve for c. And then usually they give you a point at the very end if your y equals is correct. So again, these take a lot of practice, and we're not trying to master it today. I'm just trying to expose you to it so it's not as much next time. But some of these points are still pretty easy to come by. The last one's always the hardest, of course. Okay, let's look at just one more of these for today, and then we'll jump over and knock the slope field stuff out pretty quickly. Is there anything, any of these steps that I went too fast on? This too easy? 10 steps for one question? Okay, let's look at one more for today. And I would like some feedback from you guys on what you think. So, if you were asked to solve this differential equation, you've got a particular solution, so, or we have an initial condition, so we can solve for the particular solution. So what would we do to start off? Okay. Y prime's not so good. If we've got to separate stuff, we really need to think of it as dy dx. I don't know if I would really call that a step, but that's something. Okay, what do we need to do next?
X on one side, Y on the other.
Okay, so separate the variables. Maybe add this over. Maybe divide the x over. Multiply the dx over. And I don't know. You can divide the 2 over if you want to. I usually just leave it alone. As long as you only have y stuff on the left and x stuff on the right. Numbers can be on either side. So on an FRQ, that would already get you 1 point. Now again, I'm doing several things there, so don't let me, if I'm going too fast, y'all need to speak up. I added this over because it had x's, and then I divided the x over, and then I multiplied the x over. You guys okay with that? Because that's a lot in one step. Okay, now that they're separated, what was the point of separating them? It should make the integration work out. Because we've only got y stuff over here. That one's pretty easy. We've only got x stuff over here, which makes it manageable, but it's not just undoing a power rule. So, when that's the case, we really don't have any other option but to try some u substitution. So you got to pick out a u, try it and see if it works. If it doesn't work, you need to try a different u. But it looks like, now notice, this is what I was saying a minute ago. I'm going to wait a step to integrate this. This is now u 1/2 u du. But I did integrate the right side, so technically you'd lose a point if you didn't put a plus c. It's hard to do both sides of the integration sometimes. If one of them is u substitution, you might need a step. But if you integrate something that does not have the limits of integration, you better put a plus c. Okay, raise the power by 1, divide by the new power. I'm just going to move the plus c over there. Instead of saying u, I'm going to put what u was. Okay, and we got two more things to do on this. One is they gave us information to solve for c. So you've got a choice. You can either solve this for y equals, and then plug it in and solve for c, and then plug it in where you started, or you can plug it in, solve for c, and then solve for y. And I don't know, sometimes one way is better than the others. I would say, just as a general rule of thumb, plug it in as soon as you see a c. So when y is 2, x is 1. Well, 1 squared is 1. What's the natural log of 1? So c becomes 4. And because I plugged it in here, that's where I need to plug it back in. And then our last step would be solve for y, which would just be divide everything by 2. Now again, I'm not going to make you practice a bunch of this yet, just give you the general idea. But a couple things that you can do to give yourself some confidence in your answers, because there's so many places you can make a careless mistake. One is, your final answer better solve this. If I plug in 1 for x and solve for y, it better be 2. Because if that's not true, then there's no way this can be my final answer. But that does work. And then 2, I could take the derivative of this, bring the power down, lower the power by 1, remember chain rule. If I was willing to do that for 30 seconds or so, I could see if it ended up, see, there's not any good steps to really compare it to, but sometimes you can take the derivative to check. So separate the variables so that we can integrate. Sometimes we solve for c, but we're trying to solve for y equals. So there's some algebra up front, some algebra at the end, some integration. Some integration's easy. The hardest integration's u substitution, but we don't have to do that on every single question. But they're pretty long questions. Yeah.
So if your c was on the other side,
Mm-hmm.
like, would you just like take the absolute value of it, so it would be like -4 when you solve?
No, because if you move the c over here, when you plug in this information, as long as you still solve this algebraically, your C would be -4, and that's okay, but you should be plugging it into here. You'd be plugging it into a different equation than I did. So it would still balance out. If you put a -4 here and I put a +4 here, you're just going to add yours over and make it the same as mine in the end. So that's why it doesn't matter, you just need to be consistent. Okay, so that'll be the hardest thing that we have to do in this unit. So that's just an introduction to it. Don't worry about it too much today, just wanted you to have the general idea. Okay, the slope field stuff, let's move over. This is one that you guys picked up a week ago, so you might need to find this in your binder. To be honest, when I started teaching calculus a few years ago, I did not know how to do slope fields because they never taught us this at the university level, so I thought they were kind of silly. But I can tell you, even on the AP exams, sometimes part of an FRQ is a slope field. And again, this is pretty easy to work with. So the first thing you really need to know is that derivative is just a slightly fancier way to say slope. And slope fields are kind of like graphs. So what we're going to do is we're going to plug in some x and y values, or in this case just x values, and we're going to get the slope at those specific points. So like when x equals 1, the slope would be 2. Y prime would be 2. You guys see how I'm coming up with that? What we should do with this information is everywhere there's x is 2, we need to make a line that looks like it has a slope of 2. His rise to his run, it looks like a little miniature slope. I'm aiming for this one because that would be a slope of 2. So everywhere x is 1, the derivative is 2, and derivative is slope. When x is 2, the derivative would be 3. I'm plugging it in here. So now I'm going to try to make everywhere x is 2, I'm going to try to make these look like they have a slope of 3. So I usually take a point, see where I'm aiming to, and then you got to kind of wing the rest the best you can. Should be slightly bigger than that one. What will the slope be when x is 3? So try to make it a little steeper than the previous step. What about when x is 0? So all those slopes should look like they have a slope of 1. When x is -1, slope would be -2 gives me -1, and -3 gives me -2. So it's a bunch of miniature slopes that you're drawing in. So what you're really trying to see is, depending on if you know what the initial condition is, this is kind of a visual solution to the general solution. If I don't know a particular like initial condition to start with, this is kind of a visual of what's happening. So let's say like maybe, depending on what C is, maybe it goes through this point. Well, if you kind of use these kind of like a river almost and let it kind of guide you, if this is the derivative, his solution would look like a parabola. But where it lands just depends on that initial condition. Okay, I'd like you to try number 2, and you got about 3 minutes till lunch, so if you'd please do that one, and then we will stop there for now. Now this time you don't care about the x value, you should care about the y values. So, to see what you come up with. June, I saw your sister got national merit.
Oh, she did?
Yeah.
You didn't
was-
know that? No. I didn't know either, but that's
Wait, like finalists?
Yeah.
Oh.
Yeah.
Yeah,
It's on the Fayetteville
Facebook page.
Who else did?
I don't remember.
She had a really good picture.
Benny, Jenny, Karen.
Oh, so basically like everyone.
All this one.
Okay, you know, I'm gonna text her and see if she knows, because I don't think she does.
I feel like they would tell them.
She's so cute. Yes, she is. We'll see if she knows. Oh, she wrote the message. Oh, she said yeah. She did
She's not excited? I'd be happy.
Oh, she just said yup. Like, what?
Okay, so before lunch, I asked you guys to try question 2 here, and I did peek at a few people's papers, and I saw a few different answers, so not everybody could be correct here. But let's go ahead and look at maybe like 2 more of these, jump to the end, so you can see how this sometimes comes up on FRQs, and then I'll give you some class time to finish this up. So for this one, since there's no x's in it, you only need to think about different values for y. So if y was 0, the derivative was 0. So everywhere that y is 0 should have a slope of 0. You have to put those on there. I know that one's a little bit hard to see with that line, but you do need that there. If y is 1, the slope would be 2. So everywhere y is 1, you need to try to make it look like it has a slope of 2. If it connects to this, it would be 1, so it needs to be a little bit steeper than that. And of course, all of these should look the same. If y is 2, the slope should be 4, so that's going to be much steeper. Not quite straight up and down, but a little bit steeper. And you should think about when y was -1, the slope was -2. So roughly that. And finally, when y was -2, the slope was -4. So a little bit of the slopiness is an estimation, but all of these should be the same. All of these should be the same. You were only changing y, so each y value had a unique slope. However fast you make these look like they're going up is how fast these should be going down. But you guys okay with that? If you missed some of those, is there something you need to ask? Okay, let's look at one more together then, and then we're going to skip to the back page. So question 1 just had x's in it, question 2 just had y's in it, but there can be a combination of them. So like this one, our slope comes from x plus y. So you've got to think about the point, 0, 0, 0 plus 0 would be 0. Over here, add x and y, 1 plus 0 would be 1. Two plus 0 would be 2. 3 plus 0 would be 3. Now again, sometimes it's a little easier to estimate. Like this one being 2, I was aiming for this point because it would be up 2, right 1. For this point, it had a slope of 1, so I was aiming for this because it was up 1, right 1. This one's a little bit harder, but I made it steeper. If we go the other direction, -1 plus 0 would be -1. -2 plus 0 would be -2. -3 plus 0 would be -3. So you actually have to put in some thought into the x and the y and add them together on these. So we would have, I don't know, unfortunately you kind of just have to go through each one. -1 plus 1 would be 0, -2 plus 2 would be 0, 1 minus 1 would be 0, 2 minus 2 would be 0. All of these, x and y are the same except one of them's negative. So they all have the same slope. There's a lot of pattern in here. This had a slope of 1. This should have a slope of 1. 0 plus 1. It should have a slope of, well, let's just do this one. 2 minus 1 would be 1. 3 minus 2 would be 1. Negative 1 plus 2 would be 1. Do you see how all of these are the same and all of those are the same? There's some pattern here, so that helps us as we're going along. 2 plus 0, 3 minus 1, 1 plus 1, 0 plus 2. All of these have a slope of 2. Over here, negative 2 plus 1 would be negative 1. Negative 2 plus 2, or sorry, negative 3 plus 1, 2 would be negative 1. 0 minus 1, 1 minus 2, all of these have a slope of negative 1. I'm going through the arithmetic quickly because I know that those are all the same. So I start to pick up on something. Again, you don't have to see it at all, but it does kind of help you. All of these had a slope of 0, all of these had a slope of 1, all of these had a slope of 2, all of these had a slope of negative 1, so it's just going to continue that way. This would have a slope of negative 2, negative 2, negative 2, negative 3, negative 3, negative 3, negative 4, negative 4, negative 5. Over here, these should all be the same. 2 plus 1 is also 3. 1 plus 2 is also 3. Notice these are the same, these are the same, these are the same, these are the same, these are the same. 2 plus 2 is 4. 3 plus 1 is 4. Those are the same. And 3 plus 2 would be 5. So it's the same. Now, not every question is going to have that same pattern to it, but that one, there was kind of a pattern. So as you just plug in points, you should pick up on some similarity. So, you guys okay when there's x's and y's? We're good with that? Okay, so in a moment I will ask you to come back to the front page where you should do a couple more sketches. Then the next page has been sketched for you, but it is matching. Now, one thing I want you to write down on your page here is you're not trying to match, well, they graphed the derivatives, they graphed the slope field, but they wrote the equations. So like number 7, you might want to write that the slope, the derivative is always 0. And number 8, the derivative is always 1. Number 9, the derivative is 2x. So instead of you drawing the slope fields on page 2, you just need to match them up. But you should be thinking about the derivative when you're trying to match them up, not the function. And for each of those, each one matches up with exactly one graph, so that should help you. The top of the next page is also matching. Those all fit perfectly. And then let's get down to question 19. 19 and 20 are both similar, and this is let's do number 20. This is often how it sometimes shows up as a FRQ. Sometimes on FRQs it does ask you to do a slope field. It's usually like not 20 points like this, it's something like 9 points or 16 points. Points as in not points that you earn, but points that you have to graph. And then sometimes they do stuff like this. So they've already graphed it for us, and then part A says sketch the solution curve through the point 0, 1. So if he goes through 0, 1, that would be right here. So it has to go through that. And then for the rest of the curve, you have to use this slope field. Again, it's kind of like water in a stream or something. It's kind of telling you which way to head. So based on this stuff, the way these slope fields are going, I'd assume this looks like it's going up that direction. And then over here, it looks like it's kind of flat. And then it goes up. That's what the solution curve would look like. Just let the lines kind of direct your solution curve. Okay, if I do this for B, -3, 0 has to go through -3, 0, and then his solution curve would look like this. To the left, he's going to go up. To the right, he's going to go down. Something like that. So again, you don't have to know this, but what a slope field is a visual representation of the general solution. If you know a specific point that it goes through, then we have a visual of what the particular solution would look like if it went through 0, 1, or what the particular solution would look like if it was -3, 0. That's what we are visualizing when we're doing that. Okay, so go ahead and finish up that one and then reset back to the front page. And I'm going to freeze my screen and also work those out so that we can check them and make sure that those look good before you guys leave today. So please start that over. And in about 20 minutes, I will share my answers with you to give you some quick feedback. But it's really all you need to know is slope fields. Be able to draw one, be able to match them up. And be able to sketch what the curve would look like on the last ones up there.
this, do you not like drawing lines?
I tend to draw vertical lines, which also have an undefined slope. I think on the AP test they take it either way. The problem is if you don't draw anything, it also kind of looks like you don't know. That's what worries me on that. I do have my answer to number 4 up on the board already. And there's my number 5 also. This number 6 is a pain. Give you some more time to catch up, but also you may want to critique my number 6 because again there's some pattern in there which made me feel comfortable about some of those answers, but you can see just from the side there I was having to plug in a lot to try to be careful with those numbers. But I can put up 3, 4, or 4, 5, and 6 again before class is over. So you don't have to rush or anything, but if you think you're done with 6, just eyeball it compared to mine and make sure that we're on the same track. Is that a baby?
It's Norbert's class.
It's who?
That's probably Norberg then.
Norbert?
Don't y'all make him cry pretty often?
Make him mad, for sure. He do be yelling at us. Remember he played a video?
Oh yeah, yeah, yeah. I got it.
That's fun. That's up with like 100 volume.
Yeah. I know, but I text John.
About 10 minutes from now, I'll put my answers back up for 4, 5, and 6, and then I will share my matching answers on page 2. And then you'll be on your own on page 3. But if you've got page 1 and page 2 worked out, then 3 should be fine too.
It's either A or B. I'm doing something from Kristen. Yeah. I mean, that doesn't hurt too hard. And then is it E? I thought it's not. I'm trying to do the Iris. Because Iris, my dog. Oh. I was like, what? She's so photogenic.
Cosine 0 is 1.
I don't know if photographer Kristen does it though. Or she's been shorting me. Well, I'm only doing 2 sessions here and I was more pink pants. But I'm definitely kind of nature like a feel. I don't think people are kind of I want a black romper. I don't get rompers or something. I don't know. I don't know. Just circles. Like that one. This is the one already. Yeah. So she
That looked bad.
I was just like, do you see the trend? Okay, so there is a 16. The Walk Street.
Okay, there's my answers for 3 through 6. I'll leave those up for a few minutes, and then I will show you my page 2. Okay, anything I want to ask about 4, 5, or 6 before I take it away? The hardest part is really just you've got to be disciplined. If you're doing that arithmetic too quickly, you'll miss a few of them. Okay, here, again, I'm not sharing the answers with page 3, but here's what I got for page 2. So after you do it, you need to retry some of them if you got different answers than me. But this is pretty much it for slope fields. So there'll be a question or two on the test review to remind you about them, but this is all you need to know so we don't spend more class time practicing this. You need to feel pretty good about slope fields when you're done with this handout.
So what is
But for now, you've got about 4 minutes, so maybe circle the ones you missed, jot the right answer out to the side, and then rework them before Thursday.